All right, in this video, I'm going to be going through the problems for indicator 5.3, which is solving specialty equations and inequalities. So this is quite a few problems. So let's jump right into question number 15 here. Question number 15, I have a base 3 on the left side, a base 9 on the right side. I want them to be the same base. And so here's what I know. I know that 9 is equal to 3 squared. So this side's going to stay the same. This side, the 9 is going to replace with 3 squared. Whoops, let's write the parentheses the right way. And that's then x minus 3 keeps the same power. So we're going to do a little power rule here. Power times a power. So we got 3, 7x plus 6 equals 3 to the 2x minus 6. The 3's no longer matter because they're both base 3's on the same side, or each side. So what we're left with is an equation, 7x plus 6 is equal to, whoops, why am I writing a 3 there? That's 2x minus 6. And then I need to solve this. So I'm going to subtract 2x from both sides. At the same time, I'm going to subtract 6 from both sides. So 7x minus 2x is 5x. Let's see, 6, that's gone. That's going to equal 2x minus, that's gone. And that's going to be negative 12. So divide both sides by 5. And I'll put it over here. X is equal to negative 12 over 5. All right. Number 16, part A. I want to try to solve this. All right, it's a quadratic. It's already equal to 0. And the answer is yes, I can factor it. So if I can factor it, I am going to. So let's see what we got here. This is going to split the x. Negative 20 would split with 10 and 2. Keep the 10 positive, make the 2 negative. Each of these factors is then equal to 0. And so we're going to get x is equal to negative 10 and x is equal to positive 2. All right, rolling right along. Oofed. All right. Problem part B here. This is a well, actually it is a quadratic, but it's also a trigonometric problem. So first thing I want to do is get rid of that 4. All right, so we've got sine squared theta is equal to 1/4. I'm going to go ahead and take the square root of both sides. So sine theta is equal to plus or minus. That's because we put the square root in the problem. The square root of 1/4 is 1/2. All right, now this is where I don't have the unit circle memorized. So I'm going to bounce out of the current note sheet I'm in into another problem that has the unit circle in it. And what I'm going to be looking for is anywhere sine is equal to a positive or negative 1/2. So let's go back to notes 107. All right, that has a perfectly valid unit circle on it. And I'm looking for anywhere sine. Now I got to remind myself, each of these ordered pairs is cosine theta, sine theta. So sine needs to be the y value, and I want it to either be positive 1/2. So right here is a positive 1/2, right here is a positive 1/2, here's a negative 1/2, and here's a negative 1/2. And that's at pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. All right, back to our review. There we go. All right, so back to our regular scalar program here. Theta is equal to pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. All the over 6's. All right. Part C here is another trigonometric equation. So we're going to do 2 cosine theta is equal to negative root 3. Divide both sides by 2. So I want cosine theta to be negative. Let's try and actually write a root. All right, there we go. Root 3 over 2. So again, I'm going to bounce back to my unit circle. This time I'm going to be looking for cosine values, so the x values, to be negative root 3 over 2. So our negative root 3 over 2. All right. Oop, there's my trig chart. Or it's not trig chart. My unit circle. All right, this one's just a different one. It's the same thing, though. So negative. All right, so cosine are my x values. These are all positive. All right, here's a negative root 3 over 2 right here. That's 5 pi over 6. And then here's another negative root 3 over 2 for 7 pi over 6. That one's positive. All right, so I want 5 pi over 6 and 7 pi over 6. So back to our exam. There we go. So in this case, theta is going to equal, what was that, 5 pi over 6 and 7 pi over 6. All right, a couple trig equations done. Let's see what's next. Number 17. All right, this time we have a log equation. So log base 2 of x plus 8 is equal to 3. I'm going to convert this to exponential. So my base is 2, my exponent is 3, and this is equal to the argument of x plus 8. So let's see, 2 to the third is 8. That's going to equal x plus 8. So if I subtract 8 from both sides, I'm getting x is equal to 0. So there's my answer there. Number 18. All right. Can I factor? The answer is yes, I can. Love when I can factor. So we're going to split the 2x and x. Now I've got to figure out how to split the 6 so that when I do this number times this x, and then this number times that 2x, whatever I get adds up to a negative x. I'm thinking if I put a 2 here and a 3 here, this is 3x, and then this will be 4. Perfect. So let's make the 4 negative, make the 3 positive. All right, the quick check on this, if you do it, we've got 2x times x, that is 2x squared. If I take 2x times negative 2, that's these outside pieces, that's negative 4x. If I take 3 times x inside, that's positive 3x. That's horrible to read, but it's there. So positive 3x minus 4x absolutely gets the negative x there. And then 3 times negative 2 is my negative 6. All right, all that work. Set each factor equal to 0. So let's see, 2x is equal to negative 3, which makes x equal to negative 3 halves. And yes, I prefer those fractions. I'm totally fine with it. And then for this one, x is equal to positive 2. Okay, rolling right along. Let's talk about number 19 here. I cannot factor this one. Well, that's unfortunate. Okay, so that means I have to use the quadratic formula. It's been a little while, so let's start it out. X is equal to the opposite of b plus or minus the square root, and I know I write huge, so it's going to be b squared minus 4 times a times c all over 2 times a. All right, so negative 4 plus or minus the square root. Let's see. I'll do it in parts. So that's going to be 4 squared is 16, and then minus 4 times 1 is 4, 4 times 6 is 24, all over 2 times 1 is 2. So negative 4 plus or minus 16 minus 24 is negative 8. So we've got a couple things going on with this negative 8. This is imaginary. All right, now I know I write huge, so I'll go ahead and slide this up here. I should have some space. I do. So let's see. X is equal to negative 4 plus or minus. I'm going to figure out the root in a second. I know it's going to break down, and I know I'm going to have an I there because it's imaginary. So let's break up an 8. We got 2 and 4, 2 and 2. So the square root becomes 2 times 2 times 2. So that's going to be a pair of 2's and a 2 that didn't pair up. All right, we are so close to the end. The last part is to simplify this part and then simplify this mess. So let's see, x equals negative 4 divided by 2 is negative 2, plus or minus 2 root 2i divided by 2 is just going to be root 2. I wrote that root too big, root 2, and then the I on the outside. All right, that is the quadratic formula. Ooh, all right, that was fun. So where's next? We're not done with this one? Not quite. All right, getting closer. Question number 20 here. Let's go ahead and solve the root. So we're going to, not divide, we're going to subtract 3 from both sides. So square root of x minus 4 is equal to 5. We're going to square both sides. So x minus 4 equals 25. I'm going to add 4 to both sides. And I'm going to get x equal to 29. And the answer to that is maybe. All right, you have to check your work. So off to the side here, we're going to do a quick check. All right. So right here, we've got x minus 4. Right, go back to the original. So 29 minus 4 plus 3 equals 8. So this is a square root of 25. And by the way, you could throw this in a calculator if you've got one. So let's see, 5 plus 3, 8 is equal to 8, right? All of these were equal to 8 the whole way down. True statement. Yes, x equals 29. Woohoo! All right, absolute value. The absolute value is already isolated. We're going to go ahead and split this into 2 equations. So 3x minus 8 is equal to 22, and 3x minus 8 is equal to negative 22. Let's add 8 to both sides. So 3x equals 30, divide by 3. X is equal to 10 for one answer, but there's another answer. Add 8 to both sides, so 3x equals negative 22 plus 8 is negative 14. Divided by 3. Yeah, that's not going to divide too nicely, so just leave the fractional answer. Negative 14 over 3. All right, last one in this section. Whew, all right, we're almost done, at least with this section. We have an exponential equation, and 3 to the x is equal to 80. 80 cannot be written as a base 3. So we need to apply logarithms here. So I'm going to take the log of both sides. So log of 3 to the x equals log of 80. One of our lovely logarithm properties that this exponent can fly down and be rewritten as a coefficient. It is probably the most powerful logarithm property because it's the one that takes us from exponential to a multiplication problem. And I know how to solve multiplication problems. I can just divide, right? That's how you undo multiplication. So we've got x is equal to log of 80 divided by log of 3, which no expectation that's going to happen in your head. We're going right to the calculator here. Your log button is sitting right over here on the side. So we're going to do log 80, close the parentheses, divided by log 3. And it's this answer. I always do a quick check here. So I'm going to do 3 to the last answer. So whatever that decimal is, that's 80. Okay, perfect. So this quick check does tell me that this is the right answer. And we're going to round it off to, let's say 3.99 because the 8 will round up. Okay, that was quite a few problems in the indicator 5.3 section here. A lot of work going on. As always, let me know if you have any questions or concerns, and I will do a separate video to finish it out for section 7.2. All right, we'll see you in the next one.